That's very vegan, and that's it. It's a little Arab.
So, hello everyone, Assalamu alaikum and good morning. On behalf of the organizers of Indus Water System webinar series, I, Benazir Iqbal from National Center of Excellence in Geology, University of Peshawar, Pakistan, welcomes you all. This webinar is jointly organized by National Center of Excellence in Geology, University of Peshawar, Pakistan, Geological Survey of Pakistan, Denver Museum of Nature and Science, USA, and National Center of GIS and Space Application in Geosciences, Islamabad, Pakistan. This webinar is comprised of 1 hour with 40 minutes of talk and 20 minutes for question answer session. Today we have a 10th talk of the webinar series by Dr. Muhammad Zeeshan Ali. He will give his talk about on groundwater storage depletion in South Asia from grace and ground observation. Um, uh, Dr. Muhammad Zeeshan Ali has done his master from Institute of Space and Technology, Islamabad, Pakistan, and PhD from Ching Kong University, Taiwan. His research work includes natural hazard and resource management. His PhD work is based on groundwater estimation and its effect towards the subsidence in the area. He has used a GRACE data for regional-based studies as well to focus on Pakistan and India. Currently, he is working on urban area groundwater extraction and calculate its input to land subsidence using INSAR data. So over to you, Dr. Zishan.
Thank you so much, dear organizer and all the participant, all the senior professor. Thank you so much for giving me opportunity to present my work in this webinar series. Sorry for the interruption. There was some issue regarding the connection, and I'm sorry about it. Coming toward my talk, I'm Muhammad Zeeshan Ali as organizer express. I'm thankful to her for her detailed explanation about me. My talk is about today is groundwater storage depletion in South Asia from the GRACE and ground observation data. Uh, I'm working as a research fellow in Department of Civil Engineering, International Islamic University, Islamabad. Outlines of my today presentation would be introduction, objective study area, and also coming toward the data set and methodology, result discussion, and also conclusions. Uh, as we all know that groundwater is an important component for the global water cycle. The main input for the groundwater are agriculture, industrial, and domestic activities. Like in daily life, we are using the groundwater for those type of activities, and particularly highly populated area like China and India or other arid countries are using the groundwater very rapidly, and very high quantity of groundwater are using, which further educate toward the groundwater depletion. And also maybe in the near future it will be a very big drought issue as well. Excessive groundwater extraction can lead to groundwater resource scarcity. Like we discussed whenever we use the groundwater in the excessive use, so that will be further at one day there will be a big problem for us, and it will be lead toward the socioeconomic development, affect the socioeconomic development, and also the other livelihood as well. Groundwater extraction, mostly the unmanaged exploitation of groundwater extraction in the agriculture and urban environment led to the land subsidence and reservoir depletion, which basically whenever we have the unmanaged exploitation, like we don't have a planning for it, so that further lead toward the compaction of the groundwater, and which further impact the groundwater and also the surface of the earth, which subsidizing day by day. And that is a big issue in currently in the developed countries and also the developing countries as well. In the dry season, the fresh water from the aquifer become the opportunity resource because the surface water, we have a lake of surface water, so we are using the groundwater for the all the purposes, we discussed about the domestic use and also agriculture. So whenever there is a dry season, there is a high potential of groundwater depletion, that because the usage of the groundwater is very high. So that's why they are the depletion, number of depletion, and also might be the land subsidence that can be occurred. But basically, if we talk about a little bit about the land subsidence, so that is the long-term phenomena which basically occurred in the long term, not just within the month or within the two. For the reduction of land subsidence due to groundwater withdrawal, there are two methods mostly researchers are using. First is to pre-plant the groundwater extraction, because in some cities, in the mega cities, like if we talk about China, so now Beijing and Shenzhen basically they have stopped the groundwater extraction, and in the Beijing we have a very high depletion. So now they are planning and they are making a policies for the groundwater extraction. And also the second part is artificial recharge for the where we have a very high groundwater extraction, so we can have the some a source of artificial recharge. Considering this artificial recharge, currently PCRWR is working on the artificial recharge to make this groundwater, to make the precipitation data, to make it again to the groundwater as an input. Now, why land is subsidizing? Coming toward the point that why land is subsidizing, the land subsidence is basically there are two main occurrence or causes of the groundwater subsidence, land subsidence. First is about the natural and also the human phenomena. Those coming toward the natural, like we can talk about deflation of magma and throwing of frozen groundwater or ground or the earthquake. And the second one is about the human, which is basically the groundwater or other extraction of subsurface reservoirs, which make that space within the subsurface and make that area affected from that zone specifically. Now, coming toward that, why a regional study is needed for this. I am talking about this case study, that why we need a regional study. So coming toward that, local-based relationship can be found using the ground-based monitoring. But whenever we talk about the regional study, because the ground monitoring stations can handle some of the area, but cannot handle the overall big regional scale area. Because whenever you talk about the regional scale area, there should be some similarities or some heterogeneous properties in the area, that how the groundwater level is rising or down, going down with the passage of time or with the spatial scale as well. So the multiple regional case studies has been done using the GRACE-based groundwater storage anomalies and also the INSAR-based stress and strain relationship for the to basically further to evaluate the heterogeneous properties of those type of studies. So regional study is needed to show the relationship of GRACE-based GWS anomaly. GWS means that the groundwater storage anomalies, and the groundwater variation using the remote sensing based data in many developing countries. Because whenever we don't have observance data, so further we have the process is that we need to use the remote sensing data, because we have the very enriched data of from the remote sensing. We can use it in the multiple area, and also where we don't have the groundwater observation, or if we have a groundwater observation as well. So how we can further use it for the evaluation and validation and also the calibration for the GRIS data. My research objective for this case study were the GRACE-based GWS spatial mapping, time series groundwater depletion, and also in the GWS correlation with the trim-based precipitation data, and also further we have done the estimation of depth to groundwater level from the grace-based GWS. So I will be discussing those objective one by one, and also how we have how we get the calculation and outputs. This is basically I have study area. So it includes the four countries basically, and further we have done some estimation for the groundwater level. So for that, I have considered the India area. I will be discussing in the next slide that why we have considered for the groundwater depth data for the only on India, not on Pakistan and Afghanistan, but for the special mapping based on the GRACE data, we have considered those four countries for to find the overall scenario of the groundwater depletion in the area. Data set we have used is about remote sensing data set, mostly like GRACE, TRIM, and also the GILDAS data set. The GRACE basically stand for the gravity recovery and climate experiment. Data is available globally from based on the 2003 to present with the collaboration. Those two are the those three are the publisher of the data set. They're like Center for Space Research, NASA Jet Propulsion Laboratory, and German Research Center for Geosciences. So those are the three distributor of the data set for the GRACE. So basically they have used the like the data original data set for the GRACE. We have around 3 degree, which is 330 kilometer, but those organizations have filtered the data set and downscale those data set up to 0.5 degree. So that is one of the positive thing, that how we can evaluate the data, how we can specially correlate the overall output for the data set within the special scale, within the pixel as well. GRACE is using the seasonal or annual groundwater change and storage groundwater or ice and snow as well. And for the further, GILDAS data is freely available for soil moisture, snow water equivalent, and also the canopy water equivalent. So basically, if we discuss about the GRACE data, so we have some TWS, which is the terrestrial water storage. So further, for the evaluation of the GWS, which is the groundwater storage normally, so we have to use those inputs, which are the GILDAS inputs like soil moisture and snow water equivalent, and also the canopy water storage. Coming toward the TRIM data set, basically the tropical rainfall measuring mission, that is a mission launched by the Japan Aerospace Exploration and also the NASA to find the precipitation for the climatic research, and also can be used for the meteorological analysis. This data is available basically for the northern 50 degree up to south 50 degree. That is the near to the polar region and also the tropical region. And sorry, not polar, but the equatorial. That spatial resolution is 0.25 degree, and we have further. I will be discussing that how we have used that data set to correlate the GWS for the area as well. This is our research methodology flowchart, which we have developed during my case study. First of all, we have the input data set, which is the TRIM data, precipitation data, and the GRACE data, which is the TWS data. And also, like I discussed about the GILDAS data set, and also the ground monitoring data. We have some ground monitoring data for some points as well. So further, we have correlate that for the evaluation of our GRACE-based output to correlate it with the ground monitoring data as well. So basically, first of all, the TWS, if we discuss about the GRACE data, that have some missing data. So missing data was reprocessed by using the nearly neighborhood command, one of the command in ArcGIS, and we have used that one to find the overall scenario where we have some missing data. So we have calculated that based on the nearest area. And further, we have done the monthly spatiotemporal mapping, and those mapping were further validated with the GRACE-based GWS anomaly as well. And now coming toward the TWS formation, basically TWS formation is the accumulation of GW, which is the groundwater storage, and SW. Those are all the input parameter toward the TWS, which is the main output of the GRACE data. So further, for the groundwater spatial mapping, we have basically used the GWS, which is the groundwater storage anomaly, and then we have subtract those inputs from the which are the surface, some up to some centimeter of subsurface groundwater, like soil moisture, and also some other equivalent. Those some of the part are the surface water, and also the some up to some centimeter of the soil moisture is also input with to extract those type of the water from the TWS, which we will say that the output is about the GWS, which is the groundwater storage anomaly. So further, we have done the trend analysis as well for the annual to show the annual pattern as well. For the next process, depth to groundwater level estimation and prediction approach. Basically, we have done here, we have some data from the India government. They have given us some data for the groundwater monitoring well data. They have very rich data set, by the way, for the groundwater well data. And we have taken some data for to make the groundwater level estimation maps. And further, we have used the GWR model, which is the geographically weighted regression model, that helps us to that how the spatial dependency is increasing based on the second law of geography. So that is we have conducted this analysis. First of all, we have done the estimation. We have the ground observation data from the 4 months, which is the January, and also the May, and August, and also the November. So those 4 months have some data set for the. Can you go back to the depth groundwater level estimation slide? I am a little bit explaining it. Thank you. So those things were going on. First of all, we have done the estimation with the help of groundwater and also the GRACE-based data. Those monthly depth of groundwater estimation for the GRACE-based has been used to estimate for the India. Like in the study area map, I have talked about that we have taken only the India area for the groundwater estimation depth data, because we only have the India area for our analysis from the groundwater data, but we don't have the some Pakistan or Afghanistan data. So that's why we have just focused for this objective. We just focus on the India area. So further, we have, first of all, we have done the estimation for those specific months where we have the observational data. So for the next month or the previous month, the nearest month, we have used the approach of the coefficient, the special coefficient, which we have taken from the observation data. We have used with the connection of the GRACE data to further evaluate or predict the groundwater level depth for the Feb or March or some other months where we don't have the observation data. So further, we have explained that those observation data were further evaluated with based on the ground observation data as well on the test-based analysis, and we have seen very positive results from those ones. Now coming toward the special mapping of groundwater storage anomaly. So those are the GRACE-based GILDAS GWS, where I have explained the equation that how we are taking the first of all the GRACE data, and also further later on how we are getting the GWS, which is basically this output is from the GWS maps. So those are the in northern India and central Pakistan is the most affected area from the groundwater storage depletion. We can see here that there is a very high negative values within this region, uh, where the actually the area where we have a very high agriculture in this area of India, where those states Haryana, Rajasthan, and also the Uttar Pradesh, those three states are the most affected, and also sorry, the Punjab state. Those states are most affected states due to groundwater depletion, and they are using the groundwater for the agriculture purposes. So those mostly, like according to our analysis and also from the literature, those specific area are feeding the whole India for their agriculture purposes. And we have some positive inputs as well. In the southern India, we have a high recharge in the monsoon months, where we can see the positive values are going upward, up to positive 10. So that means that we have a very high input in the monsoon as well. But as we compare it with the uh, northern area, so we don't have so positive input toward for the monsoon, because we have literature also show that this area, the northern part, have the very low precipitation for the monsoon as compared to southern part of the India. Now, coming toward the time series analysis, we have conducted the time series analysis for the where we have a very high groundwater depletion. So we have conducted some time series, like for the 17 years from 2003 to 2020. We have conducted this time series analysis, and we can see here that first of all, the missing data is also available within this specific mission. First of all, that was the GRACE data, which was up to 2016, and then we have some space within the data. And then further, the GRACE follow-up, a new mission was launched by NASA, and then now they are giving data as well. So that is basically called is GRACE and GRACE follow-up missions for the GRACE data. Those two severe areas are affected very highly. Like we can see uh, the top two graphs, which shows that the TWS and also the GWS, and we can see some correlation between the precipitation data as well. So we can here we can find that how those data is correlated highly with the precipitation inputs, and also the depletion of the groundwater whenever we don't have the high precipitation in the area, and we have a high discharge of groundwater. And further, the third one, which is the Rajasthan area, we have some groundwater decreasing trend as well, but it's low as compared to if we talk about the upper two parts of the area. Now coming toward the validation of the GRACE-based GWS with the ground observation data. So we have collected some data from the monitoring stations of groundwater storage, groundwater in the India, and that area, that specifically time series time series data was correlated with the GRACE-based GRACE-based GWS data. So that we have basically taken the data from the 2005 to 2019 from the government of India. So we have just focused for those specific years for the GRACE data as well, because the GRACE data is available for long term. But if we talk about this specific the ground observation data, so that is very limited. So we have conducted our study based on that availability of the ground data. Those outputs shows that they have very high correlation with the variation of groundwater depth level. So that it's mean that whenever we have a very high groundwater depth, that GRACE also calculated somehow the variation within the data. And we have, but some of the in some areas, we have the R square is around zero 0.6 as well. Like in the E graph, we can see here as well. This correlation show that the overall results for our analysis we have conducted for the gray space GWS extraction that have a high correlation with the ground observation data, because mostly whenever we talk about the remote sensing data, so we are focusing on the remote sensing data, but further for the validation we are using the ground observation data as well. So that is our the whole process for whenever we are talking about the ground observation data or a remote sensing based, and also a remote sensing approach uh, for some, for example, multidisciplinary analysis as well. Now coming toward the depth to groundwater level estimation from the GRACE-based GWS, further we have focused on, as I talked about, on India and Bangladesh area. So we have a very narrow data for that specific areas. So we have conducted this analysis based on the available data set. We can see here that observation data is available within the 4 months, where we have a very high observation data for those area. But if we talk about the overall months for the groundwater level table, so we can see here that here in the northern area we have some high groundwater level. So that's mean that the depletion is very high in the northern area, and also some part of the Pakistan, near to the Pakistan area. So if we in the near future we will have some data from the Pakistan government as well, so we can conduct our analysis based on those results as well. So currently here we can see here that those observation data have predicted the groundwater depth very well, and also the nearest neighbor months are calculated based on the GRACE observation data. So that is one of the interesting thing, that whenever we don't have the ground observation data, so we can use the special coefficient which is based on the geographical weighted regression model. So that model can be used as an input for the GRACE data to find the groundwater level observation data. So that in this month of monsoon, we can see a high recharge as well, where we can see the like months of August and September and October. So we have some lower the groundwater level rises with the passage of time. So that means that it have a high recharge for the area. Now, coming toward the conclusion for our research, spatial temporal mapping evaluated that the northern area is having a high groundwater storage depletion as compared to south part of the India. As we discussed in the spatial mapping as well, that we have some high peaks in the northern area, but we have some monsoon give us a high input in the southern part of the India for the months of high precipitation months. The time series analysis were done for the hotspot, where we have shown some time series analysis. So we have find that 4.4 centimeter of anomaly is going depleting for the every year for this specific locations. The monsoon season gave a high recharge to the groundwater, which can be analyzed in the spatial mapping as well. Like I discussed in the earlier as well, that how we can analyze, how we can evaluate that, how the input of the ground of the precipitation toward the moon from the monsoon is highly shown in the spatial mapping as well. Depth to groundwater level estimated maps shows that the most of the northern area is having a deep water level. So as we discussed in the maps as well, that how those groundwater level is going down, depleting and going downward whenever we have the start months where we have a very high groundwater extraction, but whenever we have some high monsoon time, so the groundwater level is rising. with the passage of time. We are conducting some related to that work. That is ongoing work. So we are conducting some new approach as well, and we are open for discussion. I would be happy to get some suggestions as well. So currently we are focusing on the land subsidence due to high groundwater extraction affected area, like where we have very high groundwater extraction. We need to focus on the land subsidence, that how much it's affecting for the land subsidence, and also predict the subsurface land subsidence according to the aquifer compactions, that how much, if we have multiple aquifers, so how it is compacting and how the land subsidence is giving input toward that one. Also, the geological settings of that specific area, for example, how those sediments are located within that area. So that is a very huge input toward the land subsidence. Whenever we talk about the land subsidence and the geological settings, the sediments, the clay, that has a very high input toward the, your analysis or your result, that how much your results are can be justifiable whenever you have some geological data for that one as well, to find the subsurface sediments, that how those are compaction level or compaction properties are high or low as well. Insert-based study can be conducted to show the overall input from the every aquifer toward the land subsidence, and also we can find the overall groundwater extraction based on the surface, that how much it's affecting the surface of the earth, and land subsidizing due to groundwater extraction can be evaluated by insert-based studies. Multiple fans like proximal and middle and distal fans affected toward the land subsidence due to groundwater extraction should be considered as well. Like we talk about some geological settings, and also the different fans of the area will be evaluated further. Thanks for your attention. Your questions are more welcome.
Thank you very much, Dr. Zishan, for such a valuable talk about the groundwater storage depletion. Now the floor is open for questions. We'll take some questions from audience. I think we have a question from
Sir Kasim
Kasim
Jan
Jan.
have some questions.
Yes, sir.
Dr. Zeeshan Ali, thank you very much. It was a very interesting presentation, and I've learned quite a bit from this. My question
Thank you so much for your great words, sir.
is not directly related to your presentation. My question is not directly related to your presentation, but there is I know somebody has requested me a few days ago, some student from Pakistan is pursuing PhD in or master's degree in China. And he requested me for some help about the problem exactly yours. He's measuring subsidence in the Islamabad area. So would you permit me to give him your email address so that he can get in touch with you?
Yes, sure, sir. It's my pleasure. Thank you so much.
Thank you.
You're welcome, sir.
We have a question from Bob and Nikias as well. So,
Yeah, thank you for your presentation. I'm curious to know the situation in Pakistan, especially water level measurements, and I want to know if you have monitoring wells, if there's some standard system where you have water level being measured on a regular basis that you can use to calibrate your systems in Pakistan, in addition to what you've done in India.
Thank you, Professor, for your interesting question. Currently, I'm working here as a research fellow in this institute. So we are focusing on some smart system where we can find the groundwater observation data. So that groundwater observation data can help us to that how we can calibrate the GRACE data. So currently, as I was not permitted to get the data from Pakistan at that time, so I couldn't done this analysis. So currently I'm focusing on that one. So in that specific case, Lahore, Kasur, and some other cities, we are targeting toward that one, so that we can have the ground observation data, and also we can evaluate it with the GRACE data. So that way, that can be help us to find the overall spatial variation, and also the time series depletion of groundwater. That how what's the scenario in the Pakistan specifically? Like we know that the Punjab is the most affected area for the groundwater depletion, because we have a very high agriculture area. So that area is affected due to groundwater extraction. So currently we are focusing on that one. We have targeted some cities as well. So we hope we can get those outputs very soon.
Thank you. And I might point out that your calibration work in India, of course, can probably be extrapolated across the border. The geology doesn't know the borders there. And it may be that you can actually project with some confidence into Pakistan based on the calibration from India.
Yes, you're right, Professor. But actually, I discussed in my future work as well, that for the near future, I will be taking the data from the geological setting as well, that how the geology is giving input the land subsidence and also the groundwater extraction. So that is our next target, that how we can find that the groundwater extraction can be affected due to the the land subsidence can be affected due to the groundwater extraction, and also the input of those sediments, and also for example what type of sediments those are. So we will be focusing on those sediments, and also the properties of those sediments, that how much their porosity, and also the hydroconductivity, those type of parameters.
Okay, we have a question from Matthias, I think.
Can
Sorry, you can
you hear me?
mute your mic. Yeah.
I'm not sure. Can I ask something?
Yes, you can.
Yes. Of course, I had exactly the same question
Yes,
at the
sure,
beginning,
Professor.
like
You're most
Bob.
welcome.
Why is it not included Pakistan? Why are the data not available? Because the problem is known for many decades. It's not a new problem. It's an old problem, which is clearly known. So maybe you should get support from some of the present people here to get really this information. The second point would be, can you already say something about what is natural based by climate change or so, and what is, and this is certainly very important, what is the reason of over-exploitation? Is there something, how can you identify the balance? And the last point would be, can you say something about the future? Can you predict what will happen if it doesn't change, the overexploitation and the climate situation? How does it look like in 10 years, in 20 years, based on your model? Thank you.
Thank you, Professor, for your first of all targeting your first point regarding the Pakistan data. So basically, when I was in Taiwan during my PhD studies, so I couldn't approach. I have sent some emails to some of the government organizations, but I couldn't get the response. But currently, I'm here. So I am connected with the PCRWR as well, one of the research organization in Pakistan, which are working on the groundwater and also the water-related research. So we are connected with them as well. So they will providing the data from now onward, from last around 2008 or 2006. They are started collecting data, but they have two data set for the annual variation. So they have interval of two, like a seasonal data. within 1 year they have a collection of 2 observations. So currently we are focusing on that data, and also we are trying to make our own smart system to monitor the groundwater level, that how it's depleting or how it's going upward. But that would be very high temporal data. Currently from the government we have the data which is around, for example, 6 months. After 6 months we are getting data, but the system we are developing is with the connection from the mechanical and electrical engineer. So they will be make some a smart system which will be giving data for the daily base and also the monthly base. So that will be very helpful for us to find the variation within the area of
Yes.
Pakistan and some specific cities. Sorry, I couldn't hear your second question, but I think you were talking about the groundwater land subsidence, 2 types, right? What is
Well,
one is
the
natural and
question
one is
was,
human based.
can you say something about natural events, maybe climate change, changes in the monsoon, and human impacts, over exploitation? What is the balance between these 2 effects, nature and humans?
Basically, if we talk about the time series analysis, so that is of course depleting. So it's mean that there is depletion, there is no balance, right? So at one time there, of course, there is a natural resource. It might be end at the one time. So if we didn't manage those type of problems, that the over exploitation should be stopped, and we need to monitor those over exploitation, and also to stop the over exploitation, but just give them, for example, some for the agriculture purpose, we can give the reservoirs water and some other part, and like precipitation data. If I talk about my own country, Pakistan, so most of the water in the name of precipitation that is going from the Indus River toward the Arabian Sea. So if we make some reservoir for those waters, so that will be a huge resource for the agriculture purpose in the near future. So that is one of the problem, that if we have those type of depletion data, so that will be problem in very near future.
Okay, thank you.
Coming toward your point, that how we can manage it. So that is one of the part is that we have the high reservoir, and also the to minimize the over exploitation of groundwater.
Yes, thank you.
Okay, we have a question from Dr. Muhammad Ashraf. So you can unmute your mic and please ask a question.
Okay. Thank you, Zeeshan, for this very interesting presentation, a very important presentation. I have just, one or two comments and then one questions. When we have recently, PCRWR has mapped and investigated the entire Indus Basin, starting from the upper Indus Basin to the lower Indus Basin. And we have also studied the complete water balance. And we have came to know, it is one of our conclusion, that overall the Indus Basin is in the equilibrium state. It is in the equilibrium state, it is sustainable. But there are localized depletion occurring, particularly in the urban settlements, in all urban settlements and in the tail of the Doabs. So my question is to you is, does this GRACE take into account those specific, the localized localized depletions? It pinpoints those depletions, number one. Number two, we have Dr. Naveed has also joined this webinar. He is attending this, and we have also studied and seen that when we apply this GRACE to a larger area, to a larger Doab, for example, to the Rachna Doab or Bari Doab, the accuracy is quite good. It may be up to 90%. The correlation is good. But when we applied this GRACE to a relatively smaller area, for example, Chaj Doab is one of the smallest Doab in Pakistan. So its accuracy or correlation falls less than 60%. So what are your findings about accuracy of this large and small basin area? So over to you. Thank you.
Thank you so much for your questions. First of all, coming to your first question, that how we can find the localized areas. I have discussed in the data set that how those data set are resampled from the 300 kilometer to 0.5 degree, which is around 67 kilometer, or up to now currently from the CSR, which is the Center for Research, Center for Space Research. They are giving us a data of 0.25 degree. So that means that 27 kilometer of spatial resolution, that is pixel, we have the data set. So currently we can focus on some small localized input as well. So if we take that type of data set, like a pixel of 27 by 27, so we can focus some of the localized area. If we talk about less than that, that is not possible by the grace, first of all. So coming to a second question, as we connecting it with the first question, that we have some special resolution. So that special resolution is basically accumulation of that whole groundwater area. So whenever we are taking the data within the big doab or within the big area, so that is basically the special spread of that groundwater is very connected to one another. But if we talk about the small doab, where we have, for example, a mountainous area and watershed is very small, so that make a problematic, because in the area where we have a big special resolution, so that is affecting overall the doab input and also the output. So for example, if we talk about a small that have some area from the other doab as well. So basically we are collecting, we are correlating it with that specific point values, but that has some input from the other doab as well. So that is one of the main input toward the decreasing the accuracy of that area, of that specific doab outputs. So that is one of the point. That is one of the
Thank you.
way we
Thank
can
you.
how we can evaluate and how we can increase the problem. Most welcome, sir.
Okay, thank you. We have a question from Mohit. Mohit, you can unmute your mic and please briefly introduce yourself and you can ask a question. Okay, we looked at him. Okay, Mohit, you can ask your question.
Yes,
I have a question.
myself, Dr. Mohit, working as a scientist in India, and I'm also working on GRACE dataset. So I have one query regarding because GRACE provides terrestrial water storage information, and on the basis of GL-DAS dataset,
Yes.
we derive groundwater storage. So I have query regarding storage. So it provides the volume because I have seen in the data set that data in millimeter or meter. Okay, but the word means terrestrial water storage means storage. What is the meaning of storage? Means it's giving the volume of that particular water storage or others. So explain it.
First of all, in storage, we are basically finding the anomalies for the those anomalies, and then like if we talk about the terrestrial water storage, so first of all we are we are extracting the gravitational pull from the model the Earth model gravitational pull from that one. So the remaining is basically the terrestrial water anomalies, right? So that terrestrial water anomalies are further some models from the Gildas data have provided us the data set for evaluating that output from which we call it groundwater storage anomalies. So that basically the volume of that data is in centimeter square by cube. But that overall, whenever we talk about the trend analysis, so that is basically the annual depleting trend for that specific area, or for example that specific pixel. So that's what we are focusing, that whenever we have a trend of, for example, 4 centimeter or 4.4 or 6 or something like that, so that is basically considering that specific area for the depleting, or for example we have some high recharge in the area. But currently in our case study, we have a very high depletion in the area. But in some case, we have some stability, and also with if we talk about the time series analysis, so we have some stability as well in the last years, and so we have some in some years we have a very high depleting points.
I have again I have query regarding storage because I am also working on Indus Basin. That Indus Basin includes Haryana, Punjab, Rajasthan, and Gujarat, some part of Gujarat region. Okay, but I am not clear about storage
Yes.
because we if we download this data set, that data comes in millimeter. Okay, and after then we use GLDS model based data set. After using such data set, we derive groundwater storage. Okay, but that's I'm not understanding about storage because the value is coming in millimeter, but storage stand for means if we think about storage, so that comes we're talking about volume, but data is not in volume format, but that is coming in millimeter or centimeter. So I have query on storage.
Basically, thank you. I got it. Basically, the way you are talking about is like the volume of the groundwater. For example, if I talk that how much volume is depleting within that specific pixel or something, so that some a researcher and scientists have some threshold for that specific values. I don't exactly remember the threshold, but they have some. For example, if we have a depletion of 1 centimeter, so that have some specific ratio for the area of pixel
Uh,
and also for
Zishan,
volume. So
Zishan,
that one is also predefined.
Zishan, can I respond to this question?
Yes, please go ahead.
In fact, we are doing similar kind of work on in Pakistan as well to find these storage changes. For example, when you have storage changes, either positive or negative, in term of centimeter, when you multiply with the total area, it will come into volume of water. So the groundwater basically fluctuating, either it is increasing or decreasing with the surface area of the area which you are basically monitoring. When you multiply with the surface area, it will give you the volume of water. So this storage changes will be the difference between the two measuring times, so it will give you minus or positive changes in term of volumes. So it is very simple arithmetic calculation in term of volumetric water, so volumetric storage. So over to you.
Thank you, Dr. Arshad.
Okay, thank you. Thanks to participants, speaker, and organizer to spare their time. I think we don't have any other questions. So I will request all of you guys to turn on your cameras for group photo. All of the participants are requested to turn on their camera. Okay, it's done. Thank you very much. Thank you, Dr. Zishan, for sparing your
Thank you
time
so
and
much.
for such a valuable talk. And thank you, organizer, and thank you, participants. We will catch you in another